Hello everyone, Mr. John here from Areteem Institute with this week's Thursday Tidbit, where we're going to be talking about search and exploration a little bit. Now, inspiration for this video comes from video games a little bit. Right, so the traditional old arcade game or early home video games have been always organized level by level. One of the most famous levels ever, World 1-1 in Super Mario Brothers. We could talk about games like Sonic, where we had games in different acts and zones. So Act 1, Zone 1 in Sonic the Hedgehog, things like that as well. Now, more recently, a lot of games have shifted into this open world type game where you have a lot of freedom in exploring. You find different areas or different levels, things like that. This has been going off the last decade, but recently even there's been a couple more series that have tried out this open world formula, right? So this last year we had the new Pokemon game, right? The new Elden Ring game. Little older, Breath of the Wild, though, was a very famous Zelda game where we had this open world that players could explore, right? You can look around, can go in any direction you want there, right? So turning this back into this idea of exploration, we have, right, the contrast between a traditional level where we had level 1, level 2, right? So this would be something like, well, we have a first level and then you go to the second level and then you go to the third level, right? So we have this very linear path of level explorations. Whereas now we have this idea of an open world. And we're going to see a little bit of this on the next slide, but a very simplified version is, right, you have some starting place, and then rather than just a single option of where to go next, we have this branching grid or things like that where you could explore next. So we have this idea then of exploration. How could a player explore? Are there systematic ways to explore, etc.? So setting this up a little bit there, let's look at the simplified map or grid that we're going to be talking about in this video. So our idea here is that you're starting at the top and then moving down to explore. So this should look pretty similar to what I was just talking about in kind of, we have this starting area and then, you could explore maybe down left or down right. In these new areas, you could explore down left or down right, things like that there, right? We're not going to say you can we're just going to worry about backtracking as going up. So I don't want to talk too specifically about how you might traverse back up this thing, but for our purposes, let's just kind of think of that as backtracking if necessary there. Right, so how does this relate to math, computer science? This is referred to as search, right? So we have this picture here, right? That's actually how it would be drawn in math and computer science, right? This grid is what we would call a tree or a graph. So we would have the nodes, we would have these edges, right? Maybe you go back and forth, things like that. And the problem here, right, with search, or the kind of solutions to search, would broadly sit into two more famous categories. We have these two famous methods or algorithms, if you like. One is a depth-first search, and the other is a breadth-first search. And so we're going to explore these a little bit, introduce them in terms of our grid as the example, and explore how they might work in general and what some of the issues might be when we come to game design and turning this back into video games as well. So, depth first search, right? Go deep, go as far down as possible whenever you can. So if we wanted to do this as an algorithm, We will in just a second. But I do want to say here, I'm going to touch on this quickly later, right? Even as a general paradigm, as a general idea, we can think of this as something a player might do, right? You pick a direction, I'm going to go this way as far as possible. Then I'll go backwards if need be, explore a new way, but you're kind of always going as far as you can every step of the way. To turn this into an algorithm, into a procedure, we have to be a little bit more specific. So here the key thing is we're going to be going down left as much as possible. Then you backtrack as little as possible to go down right, and then you go back to going down left. So kind of you keep going down left, back up a little bit, go down left again. So we're always going as far down as possible, and to make it explicit into a step-by-step procedure, we're going down left always. So looking at this in our grid, let's see how this would be explored. Right, so we have our starting point here. So I'm going to label that as 0 for our starting point. And then you go down left as much as possible. So we explore here, then here, then here. Now, we can no longer go down left. There's nothing there anymore. So we backtrack and go down right. Can we go down left anymore? No, right? Backtrack and go right. So this is 5 here. We've already gone to 4, so we don't need to go there again. Backtrack and go right. So then we have 6. We've already gone left, so then we go right again, 7. We go left always as much as possible, so then we have 8. And finally, our last position here is going to be 9. Right, so the idea is we're kind of always going left, as far down left as possible as we can in this scenario. So this is our example of how our depth first search might be working in this case. So always go left as much as possible, down left as much as possible. Now, what about another strategy? And again, this can be thought of as an algorithm, like we'll see, or kind of a general idea. Breadth first is we're going to explore the closest areas first, right? So in terms of a video game, oh, I don't want to go too far. Let me make sure I haven't missed anything in my area right here before I go down further in that case. So as an algorithm, this is a little bit weird, but right, you kind of go left, backtrack, go right. So you go left and right, then you keep track of those new areas you saw, and you repeat that process. You go down left, backtrack, go right, in those new areas, in that order, so you don't miss anything there. This algorithm probably is much easier to see in our example. So we start again at our top piece, then we go down left, and then backtrack, go down right. But now wait, we haven't explored the stuff from 1. So from 1, we explore the new areas, 3 and 4 down left and right. And then from 2, we explore the new areas. So that would be 4, which was already explored, and then 5. Right? And then we repeat this process, explore from 3, explore from 4, and explore from 5. So this makes a lot of sense in this grid, right? You could expand this if we were missing some squares, etc., which we'll see a little bit more next week as well. But that's how the breadth first search would explore this grid there. And as I already mentioned, right, these things could still be general strategies. You might not always go down left, but you might pick a direction. And if you're the depth first type of player, you want to say, okay, I'm going to keep going here as far as I can, see where it takes me, right? If you're a breadth first type player, you might say, okay, let me explore everything around me, and then I'll kind of step a little bit further away and a little bit further away and see where that leads in that scenario. Now, right, that's one complication, but that's more of our algorithm thing than anything else. The other thing I want to touch on, and this is what I'm going to leave you with to think about for next week's video follow-up, right? In a video game, typically the paths don't always branch and branch and branch, right? That's like the holy grail of video game development, that you could keep exploring and everyone would see different areas and stuff like that. But typically speaking, even if you have all of these choices of where to go, these choices start leading you back towards a kind of final area or final boss, etc. So we want to think a little bit about how these exploration methods would work on this grid now, where we have still starting at the top, but then branching towards the quote-unquote bottom area there. So we still want to start at the top, and I want you to think about before the next video how a depth-first search would explore the following grid. How would a breadth-first search explore this grid? Right, now thinking about this as a game design perspective, right? If the final area is at the bottom or the final boss, what are some pros and cons of each exploration method? And then try to think about ways maybe, right, we could do something to fix this problem, right? You can't tell a player specifically, right, oh, you can't use a depth-first search, right? At least you can't just say that to them. Maybe you can discourage them in some ways or do something more on a game design perspective. And we'll touch on maybe some of those ideas next week as well. But definitely think about how these different search methods might be applied to this grid, this graph, if you like. And we will touch back with that next week. Thank you all for watching. If you liked this, please give us a thumbs up, subscribe to the channel, it really helps us out. Stay tuned for a little bit more discussion of this next week. And if you have any ideas for new Thursday Tidbit topics, please let us know in the comments below. Thanks everyone. Goodbye.